In this project, we implemented two test scenarios using reinforcement learning for a custom maze game. The game follows the same rules as a normal maze with some exception. Each player must collect 3 golden points to finish the level. In addition, players can use two types of bombs. The first bomb destroys walls within a radius of 2 units, while the second one destroys the wall in the direction of the next player's movement. For better and faster training, all of the game levels were trained concurrently at the same time. This idea helped us to avoid overfitting and achieve better generalization in the final models. The first test scenario involves finding all golden points and proving the solvability of each level. The second test scenario is designed to test the physics of the game. In this scenario, the agent has an infinite number of each type of bombs and can test the physics of the walls to ensure the accessibility and correctness of the destruction of objects. This project produces agents that are trained for specific test scenarios and are experts in testing those scenarios by configuring the reward function of the problem. For example, Agent 1 is trained to solve the problem and gains points when it reaches golden points, while Agent 2 is trained to test accessibility of the map and gains points when it touches a new location of the map in the level. Export the results of the trained agents in a CSV file that shows the performance of the agents for each specific task. By checking the results of the agents, we can identify which maps or levels have problem in each scenarios.